You may already have had reasons. The output current has obvious distortion. The most important reason is that the output is zero for many voltage values. This is not good. So we need to try to make the whole input be in the conducting section of the diode. So there is always output current. Did you find? There is another reason. That is, in the conductive area of the diode, if the voltage range is large, that is to say it changes from here to here, then the relationship between the input and output is exponential nonlinear relationship. This is a very important reason for the distortion between the output current and input voltage of source. What shall we do? We may only limit the amplitude of the input voltage so as to make the input and output are approximately linear in a certain region. Okay, let's take a look at it along this idea. We ensure that the entire input is in the conductive area of the diode. In the case of the input signal is not too large, how can it work as we expected? Look, on the basis of such a sine signal, we put a DC signal US. It ensures that the diode always works around US. At the same time, it is a sine wave changed in a smaller range. It's like this. We ensure that the input is a small AC supposing with a DC. In this case, similarly, we can also draw the waveform of the output varying with time. When the input is US, the corresponding output may be I0. When the input increases to the maximum, the output increases to the maximum accordingly. That is to say, the output is such a waveform. You can see, because the slope here is large, we can realize the signal amplification from the input to the output. Now the input and output signal are superimposed with the DC. Before continuing, we will introduce a new concept. As we all know, this is a working point. For a nonlinear resistor, here its resistance R equals US over I0. We call it the static resistance, or RQ. As we said just now, if we need the resistor works in a small area around the working point, you can find that the linear variation of US can produce the approximate linear change of I. So in this place, there is a relationship between small delta U and delta I. We can define its slope as its reciprocal of the resistance RD at this point. RD is the meaning of the dynamic resistance. RD equals delta U over delta I. So in the field of the small signal analysis, we have two concepts for the resistance. That is the static resistance and the dynamic resistance. Here we only to review the knowledge we learned before. For such a S-type nonlinear resistance, because it works in the first quadrant, so its all static resistance are greater than 0. But in this region, according to the definition, we know that dynamic resistance are less than 0. When we were learning the op-amps, we have introduced the concept of the negative resistor. That is to say, when the reference directions of the voltage and the currents are associated, it is a line passing through the second and the fourth quadrants. The negative resistance there refers to the static negative resistance, while the one we discuss here refers to the dynamic negative resistance. The two are not the same.